What is science? I like to think of science as a tool for studying patterns in the world around us. For example, it gives us a way to study how water falls, and also a way to determine what it's made of. Science can also provide us methods in figuring out if a found mushroom species is poisonous, which can sometimes mean the difference between life or death. In my eyes, science answers a universe, nay, a multiverse of different questions, all through the simple use of three core concepts. These concepts are hypotheses, theories, and measurements. But what exactly is a hypothesis? Well, to answer that, we can easily start at the beginning. A hypothesis is, by definition, a proposed explanation to patterned phenomena. However, every hypothesis class statement must also be made falsifiable in such that it can be proven wrong through the repeated use of experimentation or further observation. In modern physics, dark matter is one of the hottest topics we hear about today. Though, even with very little foundation, it is still quite possible for us to propose an educated guess as to what might cause this mysterious form of matter to behave in the ways that it does, knowing so little about it. To do so, simply consider the following line of logic. If visible matter, otherwise known as baryonic matter, plays even a small part in the composition of its dark counterpart, then it is entirely possible that the known forces of the universe, that is, gravitational, electromagnetic, strong and weak forces, may in fact affect the movement of the dark masses. Said simply, if the invisible, newly discovered stuff turns out to be made up of the visible stuff we're used to seeing, then it's only logical to think that some portion of the previously mentioned forces also tells the invisible matter how to proceed through space and time. Now, this might seem like a load of hogwash with a big side of baloney, but no, I promise you that we have just made a fully fledged hypothesis. As mentioned earlier, one might want to verify that our statement has been made falsifiable, which it in fact has been, but how? Well, to test our claim on dark matter, we need only use the known relations or equations associated with each force in circumstances where visible and invisible matter coexist. If there are deviations from the expected theoretical predictions, then they will provide light on where to improve the hypothesis since it has clearly failed. However, should large deviations not exist at all in our experimental measurements, then this may mean that we have in fact found evidence to support our initial proposition. If we truly had supporting evidence for our initial claim, then, my dear friends, I dare say we may be on grounds to declare our hypothesis a complete theory. But that will now beg the new question of, what exactly makes a theory? Using standard convention, a scientific theory is defined to be a well-supported explanation, often described by mathematical law. Better known as the modern theory of gravity, is one of humanity's most well-known explanations. Though, since its development in the early 1900s, many other mind-blowing theories have also been produced. For instance, years after GR's development, an English physicist by the name of Paul Dirac went on to derive the foundation for what is now called quantum field theory, or QFT for short. QFT, having been around for decades, has time and time again proven itself to be indispensable within various fields of research and technologies. However, as is the case with any theory founded in mathematical logic, it is very important to remember that it's going to have many shortcomings and flaws. To elaborate further, allow me to use some drawings. You see, scientific theories, like those of general relativity and quantum field theory, are often seen as facts, ideas which are never capable of being proven wrong. This is far from true. In fact, we are actually dealing with a case in which both of our theories fail where the other one does best. To clarify, general relativity does an absolutely amazing job at describing the macro world, sometimes referred to as the world of the big or the things that we can see. It is in this regime that QFT starts to perform just a bit poorly. However, this does not mean that GR is in some sense a superior theory. Rather, it turns out that in the quantum world, sometimes referred to as the world of the very small, the same thing happens with GR in that its predictions begin to fail. The short and sweet explanation for this conundrum is in realizing that these two standalone theories were never fully developed to consider one another's perspective. The level of reality for which GR was first developed was the scales of cosmic structures and planetary systems. On the contrary, QFT was conceived for the purpose of describing distinct, individual particles, otherwise known as energy quanta, in the level of reality for the quantum world. Being that these two worlds are orders of magnitude apart, it seems only fair that we as humans have yet to find a way to bring it all together, with a single theory at least. A grand unified theory, sometimes referred to as a GUT or a GUT for short. A GUT has been sought for countless generations. Unfortunately, no physicist, at least to my knowledge, has yet succeeded in finding one. With that being said, one may now be curious enough to pursue this journey all on their own. However, before stumbling off down the rabbit hole, I think it's imperative that we both understand how to prove such theories. Though, for this, the answer is quite simple: measurements. But now, one may then rightly ask, what exactly qualifies as a measurement? Well, for the purpose of our conversation, a measurement can be defined as a meaningful value, typically numerical, which includes its proper units and associated uncertainties. In the homework set connected to this video, we will go over various ways to report a measurement in order to see the different forms that they can take on. Remember, the homework files are all entirely free and available on Patreon for the community to use and benefit from. That being said, if anyone watching this video should still be inspired to start a grand search of their own for a unified theory, please allow me to impart some advice upon you. Understand the octonions. The octonions may in fact be the key to unlocking humanity's next revolutionary theory. In time, I will be able to share with you more, but for now, this knowledge will have to suffice. Now, to solidify the lecture in our brains, I'd like to do a rather small recap on what we've just discussed. First off, we learned that a hypothesis is a proposed explanation to pattern phenomena. In our discussion, we took this topic to the realms of dark matter on the bleeding edge of science. Naturally, this led to the topics of general relativity and quantum field theory, which consequently brought us to the ideas of theories and measurements. We learned that theories, like those of GR and QFT, are simply hypotheses in disguise which possess a substantial amount of supporting evidence. Such evidence is often accepted to be proper numerical measurements. However, they can also come in various other forms as well. And with that, our recap is concluded. Until next time, ladies and gentlemen, please be safe, try to make others happy, and above all, please try to show love to yourself. We only have so much time on this planet Earth, so why don't we make the most out of it while we're still here? Peace, love, unity, and respect. Astro Dan out.